Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 10.6 entitled Factoring ax squared plus bx plus c. And what we're going to do today is we're going to factor trinomials, but now they're going to have a leading term or leading coefficient in front of that x squared. So this is the trickier type of factoring, because we have to find all of the factors of that leading term a, and we have to find all the factors of the last term c. And we have to make sure that they still add up to b. So we're going to do a method where we check our outer terms and our inner terms. So you're going to hear me say that a lot. We got to check our outers and our inners. And there's really four ways that we could successfully factor, trinomials that have a lead coefficient. We can still use the guess and check and the box method, and that's the same as we did in the previous section of notes. And there's also the triangle method and the crisscross method, and they're very similar to the box method, but I can show you those in class if you're interested, if you want to see the triangle method or the crisscross method. And for our purposes, we're probably just going to stick to guess and check and the box, just because sometimes if you get too many options, then students tend to get confused. So let's take a look at this first trinomial here. And we have 2x squared plus 11x plus 5. And we're going to factor it. Now in class I can do all four methods, but here I'm just going to do guess and check and box. And there's a little note up above here that says make sure we take out the GCF. Okay, so we want to look at all of our numbers and see if we can take out a greatest common factor. If we can do that, that makes our numbers smaller, and it'll make it much easier to actually find all of the factors that we need. So if I look at the 2 and the 11 and the 5, I don't have any common factor between those three numbers. So here I can't take out a greatest common factor. But if I'm going to factor this using the guess and check method, I need all of the factors of 2 and all of the factors of 5. So the factors of 2 are just 2 and 1, basically, or 1 and 2. And the factors of 5 are just going to be 5 and 1, or 1 and 5. So this one's not so bad because we don't have a lot of different combinations to try out here. But I'm going to set up my parentheses. And now if that 2 wasn't in there, in that spot in front, I would just put an x and an x. But since a 2 is there, now I have to do the 2x and a 1x. So I need to put the factors of 2 in front of those x's. Now here's where the guessing and the checking comes in, because now I need to fill in these other spots with the 1 and a 5. And I got to figure out where the 1 goes and where the 5 goes. Now they need to, when I multiply them, they have to add up to 11. So let's just put the 1 here, and let's put the 5 here, and then let's check. Okay? Now my checking process is where I check the outer terms, which means I multiply the outside terms. So 2 times 5 is 10. And then I check my inners. 1 times 1 is 1. Now a 10 and a 1 can get me to 11. They can get me to that middle term if I add them. So I'm going to make that a plus and make that a plus. And there I go. I factored the trinomial. Now if I wanted to double check this, I could double check my work. I could do the 2x times the 1x, which would be the 2x squared. And then the 2x times the 5, which would be the 10x. That's why we have this 10 here. And the 1 times the 1 is the 1x. That's why we have this 1 here. And then the 1 times the 5 is the 5. And then when I combine my middle terms, I get 11x. So I get that original trinomial that I started with. So you can check your work for these, and that's a good skill to do. But if you check your outers and your inners, it's kind of like you're checking your work in a way. Okay, let me show you the box method as well. And again, this is where we're going to set up our box. We're going to put our 4 squares inside the box. We don't need any diagonals. But my first term goes in the first box in the upper left, and my last term goes in the lower right box. And then what I need to do is I need to multiply the 2 and the 5. So 2 times 5 is 10. So I need all the factors of 10. Well, that's 1 and 10, or 2 and 5. But I need the factors that are going to add up to 11. So 1 and 10 will get me to an 11 if I make them both positive. So now I'm going to put a 1x and a 10x in those other 2 boxes. And again, it doesn't matter where you put them. And then just like before, you're going to take out a GCF. So if I look at my row here, I have an x in common. If I look at the bottom row, I'll have a 5. If I look at this first column, I'll have a 2 and an x. And if I look at this last column, they don't have anything in common, so that's just a 1. Now the 1 and the 5 are positives. So now if I rewrite those GCFs in their own little parentheses, I have my factored form. Okay, so sometimes students prefer the box method for this type of factoring because it does have a little bit more structure and there isn't as much guessing. But just a little caution, sometimes the box method can be a little tricky with the signs and making sure that you have the right positive or negative. Okay, so if you want to see more of the box method, we can definitely demonstrate that in class. But for example 1 here, when we're factoring, I'm going to stick mostly to the guess and check method. And remember, whatever method you pick, you still get the same answer. So for example 1, part A, I have 2x squared minus x minus 3. So no matter what method I use, I need the factors of 2 and the factors of 3. Well, the factors of 2 are just 2 and 1. So I'm going to have a 2x and a 1x. And the factors of 3 are going to be a 1 and a 3. Now, again, it doesn't really matter where I put the 1 and the 3. I can guess, and then I'll check. And if I don't get them right, then I'll erase them and relocate them. Okay? So let's just put the 3 here and the 1 here for now, and then we'll check. So if I check my outers, 2 times 1 is a 2, and my inners, 3 times 1 is a 3. Now I have to add up to this middle term, and then remember this is a negative 1x. So 3 and 2 can get me to a negative 1 if I make the 3 negative. So I'm going to put a negative in front of the 3 here, and then I'll leave a plus in front of this one so that I get a positive 2. And there I factored. Okay, for part B, same process. I need the factors of 5 and the factors of 3. So the factors of 5 are just 5 and 1. So I'll need a 5x and a 1x. And the factors of 3 are going to be 1 and 3. Again, it doesn't matter where I put them. And then I'll check my outers and inners. 5 times 1 is 5. 3 times 1 is 3. Now 5 and 3 have to get me to a 2. And that will happen if I make the 5 positive and the 3 negative. So the negative needs to go in those parentheses there. Okay, for part C, I still need the factors of 3 and the factors of 44. Okay, this time there's a lot more factors of 44. So, factors of 3, I'm going to need a 3. This time it's a C and a 1C. Doesn't really matter what the variable is. Factors of 44, let's see, I could have 1 and 44. It's probably not going to be 1 and 44. I could have 2 and 22. I could have 4 and 11. Now somehow I have to get to a 37. Okay, so here's where, again, you have to check and or guess, and then you have to check your guess to see if it actually works. So I know I'm going to have to multiply something by 3, and I'm trying to get to 37. So if I had something that was like close to 10, 3 times 10 is 30. So that would get me into the 30s. So maybe I need the 4 and the 11 to try first. So let me put the 11 here and the 4 here, and then I'll check my outers and inners. And if they're not right, then I'll flip-flop the location of the 4 and the 11. And if that doesn't work, then I'll just get rid of the 4 and 11 altogether, and I'll try the 2 and the 22. Okay, so outers gets me a 33. That's good. Inners gets me a 4. Oh, that's very good, because now 33 and 4 can get me to a negative 37 if I make both of them negative. Okay, last one. 24 r squared minus 6r minus 45. Now, remember how we had that previous note about taking out a GCF? If you look at these numbers, 2 and 6 and 45, we can take a GCF out of them. Okay, so I'm going to put a little star here with GCF, because we can take out that greatest common factor from those 3 numbers. That greatest common factor is going to be a 3. 3 goes into 24 8 times. 3 goes into 6 2 times. And 3 goes into 45 15 times. So now instead of needing the factors of 24 and the factors of 45, I need the factors of 8 and the factors of 15. So that's a lot nicer numbers to work with because they're smaller. Now the factors of 8, I could have 1 and 8, or I could have 2 and 4. And the factors of 15, I could have 1 and 15, or I could have 3 and 5. Now most of the time when we're doing this type of factoring, unless it's a prime number, you're probably not going to use your factors that are 1 and the number itself. Most of the time. So to begin my guessing of what factors I need, I'm going to try the 2 and the 4 and the 3 and the 5. So I'm going to leave that 3 out front, and then I'm going to set up my 2 parentheses. Then I need the factors of 8, so I need the 2 and the 4, so 2r and 4r. And then I'm going to try the factors of 3 and 5 as my factors of 15. So let's see, they have to add up to a 2, so let's see if I can kind of visualize this. If I took the 2 times 5, that would be 10. And then the 3 would have to go here, and the 3 times the 4 would be a 12. Okay, so let's try the 3 here and the 5 here, and then we'll check. Okay, my outers gets me 10r. My inners gets me 12. Now I need them to add up to the negative 2 here. Not the negative 6 from the original problem, because I took out the 3. Okay. And so in order to get 12 and 10 to add up to a negative 2, the 12 has to be negative. So that means I need the 3 to be negative, and then the 10 and the 5 have to be positive. There we go. There's my correct factorization. Now, even if you didn't take out a GCF first, you could still factor. You would just have bigger numbers. You'd probably be dealing with 12 and 15, like 12 and 2 and 15 and 3 as factors of 24 and 45. Okay, but if you take out the GCF, then you have smaller numbers to work with. Okay, now our only other example has these 2 parts to it, and these are equations. So we're going to factor just like we did, and then after we factor, we're going to solve by setting each of the little parentheses equal to 0. Okay, so I have 3b squared plus 26b plus 35. Now I want to look for a GCF if I have one, and it looks like 3 could be a GCF, but 3 doesn't go into 35. So I don't think I have a GCF here, but I do need my factors of 3. So I'll need a 3b and a 1b. And then I need my factors of 35. So that's 1 and 35, or it could also be 5 and 7. 5 times 7 is 35. So let's try the 5 and the 7. Let's see, let's just put the 5 here and the 7 here to try and see what we get. For my outers, I get a 21. My inners, I get a 5. Oh, 21 and 25 will get me to that 26 if I make them both positive. There we go. There's my correct factored form, and it's set equal to 0 now because it's an equation. So now I can take each little parenthesis and set it equal to 0. So I'm going to subtract the 5 over and then divide by 3. So I get negative 5/3. And again, that's okay if you get a fraction. Just make sure it's reduced. You can leave it improper like this one. And here I would subtract the 7 over, so I would get negative 7. Now to check my answers, I would want to take each of these values for b and substitute them back into the original equation and make sure I got a true statement. Okay, for part B then, this equation is just slightly different because it's not set equal to 0. So I have to subtract that 12 over first. That way I'll have all my terms on one side of the equation, and now I can look for a GCF and begin to factor. Now there isn't a GCF for 7 and 40 and 12, so I'm just going to need the factors of 7 and the factors of 12. So factors of 7, that's just 1 and 7, so 7n and 1n. And then the factors of 12, let's see, that could be 1 and 12, or 2 and 6, or 3 and 4. And now I have to try and get them to add up to 40. That's my middle term right there. So, I'd have to multiply 7 by something that got me maybe close to 40. 7 times 6 is 42. So let's try that. Let's try the 2 and the 6. And if that doesn't work, then I'll flip-flop their locations. And if that still doesn't work, then I'll try another pair. So if I check my outers, that gets me 42. And my inners, oh, that gets me 2. 42 and 2 will definitely get me to 40 if I make that 2 negative. So the 6 will be positive and the 2 will be negative. And now I can set each of those parentheses equal to 0 and solve. So I'll add the 2 over, and then I'll divide by 7, and then I'll subtract the 6 over. And again, you could check to make sure those answers are correct by substituting them back into the original problem. So if I did negative 6 squared, that'd be 36 times 7, and then 40 times negative 6, and I'd have to combine them and make sure I got 12. And you will if you check that. Okay, so I know for the notes here I was demonstrating mostly the guess and check method with the outers and the inners. But if you want to see the box method or the crisscross method or the triangle method, we will definitely go over that more in class. So try these problems for practice. If you get stuck, you can look at the odd problems in the back of the book. There's a few odds. Or come on in and see us before school.